NEC 600.32 addresses neon secondary circuit conductors over 1000 volts, nominal. Specifically, let's examine 600.32 ATWO, which states that conduit or tubing shall contain only one conductor. This requirement at first glance appears straightforward. However, the question arises whether this applies to all conductors, including the equipment grounding conductor, or only to the secondary circuit conductors themselves. Interpretation No. 4510-13 clarifies this point. It states that the requirement of NEC 600.32 ATWO does not apply to the equipment grounding conductor. This means that the equipment grounding conductor may be installed in the same conduit or tubing as the secondary circuit conductors. There is a caveat. This is provided that the equipment grounding conductor is installed in accordance with NEC Article 250. Therefore, running the ground wire in the same conduit as the secondary conductors is permissible under NEC 600.32, as long as Article 250 requirements are met. Now let's turn to NEC 600.32 FR. This section states that nonmetallic conduit or tubing used for secondary circuit conductors shall be listed and shall have a wall thickness of at least 0.6 inch or 1.5 mm. The question here is whether this precludes the use of nonmetallic conduit for the ground wire. The equipment grounding conductor for a neon secondary circuit is not considered a secondary circuit conductor. Therefore, the requirement of NEC 600.32 FR does not apply to the equipment grounding conductor. This means that it may be installed in nonmetallic conduit or tubing, provided other applicable requirements are met. In conclusion, based on the clarifications provided by NEC Interpretation No. 4510-13, it is permissible to run the ground wire for a neon secondary circuit in the same conduit or tubing as the secondary conductors. This is irrespective of whether the conduit or tubing is metallic or non-metallic. It is crucial to ensure that the ground wire is properly installed and meets all the requirements outlined in NEC Article 250. Let's delve deeper into NEC Article 250, which governs grounding and bonding. Article 250 provides comprehensive requirements for ensuring electrical safety through effective grounding. When installing an equipment grounding conductor in the same conduit as neon secondary circuit conductors, several key aspects of Article 250 must be considered. Firstly, the size of the equipment grounding conductor must be adequate for the rating of the overcurrent protective device in the circuit. Table 250.122 provides guidance on the minimum size of equipment grounding conductors based on the rating of the overcurrent device. Secondly, the equipment grounding conductor must be connected to the equipment grounding bus or terminal at the service equipment or separately derived system. This connection ensures a low impedance path for fault current to return to the source, facilitating the operation of the overcurrent protective device. Thirdly, all metal enclosures, such as junction boxes and enclosures for transformers, must be properly bonded to the equipment grounding conductor. Bonding ensures that these metal parts are at the same electrical potential as the equipment grounding conductor, minimizing the risk of electric shock. Furthermore, the path to ground must be continuous and permanent. Any splices or connections in the equipment grounding conductor must be made using approved methods such as listed connectors or terminals. Avoid using methods that may compromise the continuity of the grounding path, such as wire nuts alone. In addition to these general requirements, there are specific considerations for neon sign installations. The secondary circuit of a neon sign transformer operates at high voltage, typically several thousand volts. Therefore, it is essential to use appropriately rated equipment and wiring methods to ensure safety. When installing the equipment grounding conductor in the same conduit as the secondary circuit conductors, care must be taken to maintain adequate separation between the conductors. This helps prevent insulation breakdown and potential short circuits. Also, the conduit itself must be properly supported and secured to prevent damage. The NEC provides guidelines on conduit support spacing in Article 352 and other relevant articles. Now let's consider the use of nonmetallic conduit for neon sign installations. While NEC 600.32 specifies requirements for non-metallic conduit used for secondary circuit conductors, it does not preclude the use of non-metallic conduit for the equipment grounding conductor. However, it is essential to select a non-metallic conduit that is listed for the intended use and has adequate mechanical strength and temperature rating. The conduit must also be installed in accordance with the manufacturer's instructions and all applicable NEC requirements. When using non-metallic conduit, it is important to ensure that all fittings and connections are properly made to maintain a watertight and secure installation. Non-metallic conduit fittings must be listed for use with the specific type of conduit being used. Also, the conduit must be protected from physical damage such as impact or abrasion. The NEC provides guidelines on protecting conduit in areas where it is subject to damage in Article 300. Another important consideration is the location of the neon sign transformer. The transformer must be installed in a readily accessible location and protected from the weather. The transformer enclosure must be properly grounded to the equipment grounding conductor. Also, the secondary circuit conductors must be routed in a manner that minimizes the risk of contact with grounded metal parts. The NEC provides guidelines on clearances for high-voltage conductors in Article 600. In addition to these installation requirements, it is essential to perform regular maintenance on neon sign installations to ensure continued safety and reliability. This includes inspecting the wiring, connections, and equipment for signs of damage or deterioration. Any damaged or worn components must be replaced promptly. Also, the grounding system must be tested periodically to verify its effectiveness. Ground impedance testers can be used to measure the impedance of the grounding path and ensure that it is within acceptable limits. Finally, it is important to be aware of any local amendments or interpretations of the NEC that may apply to neon sign installations. Local jurisdictions may have additional requirements or restrictions that must be followed. It is always a good practice to consult with the local electrical inspector before beginning any electrical work. By following these guidelines and adhering to the requirements of the NEC, you can ensure that neon sign installations are safe, reliable, and compliant with applicable codes and standards. Remember, electrical work can be dangerous, and it is always best to consult with a qualified electrician if you have any questions or concerns. Now let's delve into some specific scenarios and common questions that arise when dealing with neon sign wiring and grounding. One frequent question involves the use of flexible metal conduit, or FMC, for connecting the neon sign transformer to the sign electrodes. FMC is often used in these applications due to its flexibility and ease of installation. However, it is important to ensure that the FMC is properly grounded. If the FMC is used as the equipment grounding conductor, it must meet the requirements of NEC 250.118. This section specifies the conditions under which FMC can be used for grounding, including limitations on length and the use of listed fittings. In many cases, it is preferable to install a separate equipment grounding conductor inside the FMC to ensure a reliable grounding path. Another common scenario involves the use of ground fault circuit interrupters, or GFCIs, for neon sign circuits. While GFCIs are not typically required for neon sign circuits, they can provide an additional layer of safety, especially in outdoor or damp locations. If a GFCI is used, it must be properly sized and installed in accordance with NEC 210.8. Also, the GFCI must be compatible with the neon sign transformer and the characteristics of the secondary circuit. Another important consideration is the voltage drop in the secondary circuit conductors. Due to the high voltage and relatively low current of neon sign circuits, voltage drop can be a significant issue, especially in long runs of conductors. Excessive voltage drop can cause the neon sign to appear dim or flicker. To minimize voltage drop, it is important to use conductors of adequate size and to keep the conductor runs as short as possible. The NEC provides guidance on voltage drop calculations in Chapter 9. Another area of concern is the protection of neon sign transformers from overloads and short circuits. The NEC requires that neon sign transformers be protected by overcurrent devices such as fuses or circuit breakers. The size of the overcurrent device must be selected based on the rating of the transformer and the characteristics of the secondary circuit. Also, the overcurrent device must be readily accessible and properly labeled. In addition to these electrical considerations, there are also mechanical requirements for neon sign installations. The sign must be securely mounted and supported to withstand wind and weather conditions. The sign must also be located in a safe location where it will not pose a hazard to pedestrians or vehicles. The NEC provides guidance on the mechanical installation of signs in Article 600. Another important aspect of neon sign installations is the proper disposal of old or damaged neon signs and transformers. Neon signs contain gases such as neon and argon that can be harmful to the environment. Also, neon sign transformers may contain hazardous materials such as polychlorinated biphenyls or PCBs. It is important to dispose of these materials properly in accordance with local regulations. Many jurisdictions have specific requirements for the disposal of neon signs and transformers. It is always a good idea to check with the local authorities before disposing of these materials. In conclusion, neon sign installations require careful attention to detail and adherence to all applicable codes and standards. By following the guidelines outlined in the NEC and other relevant regulations, you can ensure that neon sign installations are safe, reliable, and compliant. Remember, electrical work can be dangerous, and it is always best to consult with a qualified electrician if you have any questions or concerns. Now, let's address the question of whether it's appropriate to have a friendly debate with the local electrical inspector regarding the interpretation of NEC 600.32. While it's important to understand the code and advocate for your interpretation, approaching the inspector with respect and a willingness to learn is crucial. Instead of framing it as a debate, consider it a discussion to clarify the inspector's understanding and to present your reasoning based on the code and the interpretation provided by NEC Interpretation No. 4510-13. Prepare your arguments with code references and any supporting documentation. Listen carefully to the inspector's explanation and be open to their perspective. The goal is to reach a mutual understanding and ensure compliance with the code while maintaining a positive working relationship with the inspector. Remember that the inspector's role is to ensure public safety, and their interpretation of the code may be based on local conditions or specific concerns. In some cases, it may be necessary to seek clarification from the NEC itself or from a qualified electrical consultant if a disagreement persists. However, always strive to resolve the issue amicably and professionally.